Yes, good morning, all of you. Good morning, students. Today, I'd like to discuss on the topic plastics and types of plastics. So, coming to the plastics, plastics are the important substances or polymeric substances which undergo deformation on applying high pressure and high temperature. On the other side, we have resins. Resins are the basic binding materials which forms a major part of the plastics. Therefore, resins and plastics are called as synonyms. So, coming to the plastics are having certain important properties. They are low in its cost, very easy to handle, and they have good corrosion resistance. They have good abrasion resistance, and they have very good electrical insulating and thermal insulating properties. And some of the plastics also have good mechanical properties, and these plastics are showing resistance to almost all type of chemicals. And next we have uses of the plastics. Plastics mainly used in household purposes as well as for the manufacturing of the furniture. And coming to the disadvantages of the plastics, when they subjected to heating, some of the plastics gets softened on high temperature. That means the melt on high temperature. That's one of the disadvantage. And the second one is these plastics are non-biodegradable substances. So this is the second point related to disadvantage. And coming to the next important types of plastics. Here there are two types of plastics: thermoplastics and thermosetting plastics. Coming to the thermoplastics are the plastics which soften on initial heating and harden on final cooling. On further reheating, they can be converted into, or they can be molded to different forms, and these plastics are called as thermoplastics. So these are the thermoplastics. Okay, coming to thermosetting plastics. Thermosetting plastics are the plastics on initial heating they get softened, on final cooling they get hardened, and on reheating they will be set into one particular form or molded to one particular shape, and that's why these are called thermosetting plastics. Once they are heated, these thermosetting plastics can be molded, shaped and pressed into shapes. Once they set, they cannot be reheated since they are permanently set, and these type of plastics are called thermosetting plastics. So coming to the second important point related to thermoplastics. Thermoplastics are the plastics which have weak secondary van der Waals forces of attractions present between the two long linear chain polymers. That is the second point of thermoplastics. On the other side, we have thermosetting plastics. These thermosetting plastics They are made up of long chains of molecules that are cross-linked, and they have very rigid structure. That is the second point of thermosetting plastic. So if you distinguish between the thermoplastics and thermosetting plastics, we will be having some very important differences between thermoplastics and thermosetting plastics. So the distinction between thermoplastics and thermosetting plastics is basically mainly dependent on the various important characteristic properties and as well as their applications. Let us go for the differences between the thermoplastics and thermosetting plastics. If you take the differences present between thermoplastics and thermosetting plastics, the first important major difference is that the thermoplastics can be synthesized by the process called addition polymerization, whereas thermosetting plastic are synthesized by condensation or step polymerization. So thermoplastics can be synthesized by the process of addition or chain growth polymerization, whereas thermosetting plastics are synthesized by condensation or step polymerization. And coming to the second point, thermoplastics is processed by injection molding, extrusion process, blow molding, thermoforming process, and rotational molding, whereas thermosetting plastic is processed by compression molding, reaction injection molding. So coming to the third point of the difference present between thermoplastics and thermosetting plastics, thermoplastics have weak secondary van der Waals forces of attractions present between the molecular chains, whereas thermosetting plastics, they have strong covalent bonds present between the molecular chains. Next point, the thermosetting plastics and thermoplastics have got the chains. So thermoplastics form long linear chains, whereas thermosetting plastics form cross-linked chains. So thermoplastics forms or thermoplastics results in formation of long linear chains, whereas in the case of thermosetting plastics, cross-linked chains are formed between the molecular chains. The next point is thermoplastics have low melting points and low tensile strength, whereas thermosetting plastics, they have high melting points and high tensile strength. The next point, thermoplastics are formed by the addition polymerization, and therefore there are no byproducts that are going to be formed, and here the thermoplastics can be recycled and they can be reused, whereas thermosetting plastics, they are formed by or they will undergo condensation polymerization, and here the thermosetting plastics cannot be recycled and reused. Next point, thermoplastics, they have got lower in its molecular weight, whereas thermosetting plastics, they have got high molecular weight. And the next point, thermoplastics can be reclaimed from the wastes, whereas thermosetting plastics cannot be reclaimed from the wastes. The next point, thermoplastics are soluble in almost all organic solvents and other solvents, whereas thermosetting plastics are insoluble in almost all of the solvents. And coming to the examples of these thermoplastics and thermosetting plastics, thermoplastics are given with some of the examples like polyethylene, polyvinyl chloride, and polystyrene. Even Teflon is also taken as an example for thermoplastics. On the other side, thermosetting plastics, they are given with examples like bakelite, urea formaldehyde resin, polysilicones, and polyesters are the examples of thermosetting plastics. So you can see it here. The examples of thermoplastics are polystyrene, Teflon, acrylic, nylon, whereas examples of thermosetting polymers or plastics: vulcanized rubber, bakelite, polyurethane, epoxy resin, and vinyl ester resin. And some of the questions that are frequently asked, what are the examples of thermosetting plastics? Just now we have learned epoxy resin, urea formaldehyde resin, bakelite, polyesters, and polysilicones. And the next question, what is the difference between thermosetting plastic and thermoplastic? The main difference between thermoplastic and thermosetting plastics are: here, thermoset is a material that strengthens when heated but cannot be remolded or heated after initial forming, whereas thermoplastics can be reheated, remolded, and cooled as needed without causing any chemical changes. And next question, how are thermosetting plastics used in everyday life? So in our everyday life, they are used in construction equipments, construction equipment panels, electrical housings and components, insulators, cell tower tops, heat shields, circuit breakers, agricultural feeding troughs, motor components, and disc brake pistons. And coming to the next question, what are the applications of thermoplastics? Main applications of thermoplastics are: they are reusable plastics, therefore they are used in containers, ropes, carpets, piping system, car batteries, electrical cable insulators, and gas liquid filters. And the final question, is thermoplastic toxic? Okay, the answer is any product or a material can be potentially or inherently toxic or safe depending on variety of factors. You see, depending on the various factors, the toxicity is dependent. You see, thermoplastic is not necessarily toxic. It is safe in a wide range of applications. It is also used in biomedical applications also. Okay, this is about thermoplastics and thermosetting plastics. And students, today we have learned about thermoplastics and thermosetting plastics, the differences between thermoplastics and thermosetting plastics, and examples of thermoplastics and thermosetting plastics. Hope you all understood. Thank you.